Hello everyone, welcome back to Mission VTU YouTube channel. Now we are dealing with the 3A question, that is derive the drain current equation for a MOSFET in linear and saturation region. So before we dive into the derivation, let's understand some basic terms and parameters. So ID, drain current, VGS, gate to source voltage, VDS, drain to source voltage, VTH, threshold voltage, UN, electron mobility, COX, gate oxide capacitance per unit area, W, width of the channel, and length, L, length of the channel. Okay, this is the NMOS enhancement mode MOSFET. In this, in linear region, that is non-saturation region, this is the diagram of non-saturation region. Okay, so the condition here is VGS is greater than VTH and VDS is less than VGS minus VTH. So in this region, the MOSFET channel is formed and behaves like a resistor. So the charge per unit length in the channel Q is equals to minus COX into VGS minus V of X minus VTH. The local current at a point X along the channel ID is equals to W into Q into V. So which is equals to W into C of X of VGS minus V of X minus VTH into UN into dV by dx. Here say, Q is substituted by this C of X. Next, separate the variables and integrate it from source to drain over length L. The equation goes like this: ID is equals to UN COX W bar L integration from 0 to VDS VGS minus V minus VTH into dV. Next, ID is equals to UN COX. If we integrate this, W bar L and VGS minus VTH into VDS minus VDS by 2 the whole square. Then ID is equals to K dash W bar L into VGS minus VTH VDS minus VDS the whole square by 2. Here K dash is mu naught COX and beta is equals to K dash into W bar L. The final equation is ID is equals to beta into VGS minus VTH into VDS minus VDS square by 2. Next, in the saturation region, the condition is VGS is greater than VTH and VDS is greater than or equal to VGS minus VTH. This is the diagram of in saturation region NMOS enhancement mode MOSFET. Here the channel pinches off near the drain and current becomes independent of VDS. Here you can see the pinch off near the drain. At the point of pinch off, VDS is equals to VGS minus VT. Substitute this value in the linear equation. What is the linear equation? ID is equals to K dash W bar L VGS minus VTH VDS minus VDS the whole square by 2. So here you can substitute. ID is equals to K dash W bar L VGS minus VT into VGS minus VTH minus VGS minus VTH the whole square by 2. Next, ID is equals to K dash W bar L VGS minus VTH the whole square by 2. Okay. Next, ID is equals to take out 1 by 2 common, 1 by 2 K dash W bar W by L VGS minus VTH the whole square, and the final equation is ID is equals to half beta VGS minus VT the whole square. And this is the summary of the 3A equation. Here in the linear region, the condition is VGS is greater than VTH and VDS is less than VGS minus VTH. Here the drain current equation is ID equal to beta into VGS minus VT into VDS minus VDS the whole square by 2. In saturation region, the condition is VGS is greater than VTH and VDS is greater than or equal to VGS minus VTH, and the drain current equation is ID is equals to half beta into VGS minus VTH the whole square. Okay, in the next video we will see 3B answers. Till then, stay tuned with us. uh, uh, if you like this video, uh, hit the like button and subscribe the channel and share with your friends. Thanks for watching.